Sorry for the delay. We are now live on this session with Anders Brännström. Time to market is essential for success. Anders works with us here at Inmotion Technologies as application manager. So all the application projects that we are developing here at Inmotion Technologies is handled by Anders and his team. So I hand over to Anders. Welcome.
Thank you very much for that introduction. Hello, everyone. I think this title for the presentation is the longest I have had by far. You have probably listened to many visions of what lies ahead in the future when it comes to electrification. We at Inmotion have been part of electrification for a long time, and I would like to share some insights we have from working for decades with electrification in both industrial and also automotive applications. I hope that by sharing our experiences, we can all make this shift faster. Many of my colleagues are motivated because we truly believe in that will lead to a more sustainable future. And by working together, we can increase that pace. My name is Anders Brännström, as shared before, and I lead a team of application engineers. We are situated here in Stockholm, Sweden. We have a lot of experience from working with customers around the world. I have also reached out to my colleagues here at Inmotion to collect tips and tricks that I will share within the time we have for this presentation. I would start. See if we can switch screen. Yep. As I prepared the agenda for this meeting, I decided to present our tips and tricks in chronological order, divided into phases. When you start your electrification, or if you're already on the way, it is important to think about the entire life cycle from idea to upscaling, both on several product lines and in operation, as well as service and after sales. We at Inmotion can be with you from the moment that you start exploring and defining your own journey and continue throughout development. We can also support on your continuation, either if it starts with a product and continues with more product lines, as well as service and after sales. It is normal for our customers to have a product life cycle of about 10 years. Even from the day of end of life. I know that some of our products we still manufacture and deliver to our customers since the 90s. The whole journey starts towards electrification can be divided into phases that begin with what I would call an initiative. A company can, for example, initiate the shift either from internal development, for example, driven by technical departments such as research and development, R&D, or it can be initiated from customers and competitors and be market-driven. Customer requirements can come from legal requirements related to environments such as pollution or performance and uptime. Based on my experience, it is important to justify why you make the shift, because it will compete with the current business case and may challenge your company's way of making revenue. Define and create long-term goals. This will help create an understanding of investments along the way. Although tools are available for your electrification, you will need to do iterative testing to find the most competitive solution, which could possibly change the way that you are doing business today. I would also like to say, trust your own organization. Many times, you will find talent and drive. Empowering employees will help motivate and engage. Do not start by recruiting external resources. Instead, find a good partner, increase knowledge within the company. Domain knowledge that involves understanding your customer is probably more important than technical skills within electrification. This is, of course, where we as a product line company can help with knowledge and expertise in electrification. Many tips in this presentation will be related, working together with a partner and supplier, and that could, for example, be Inmotion. I will continue referring to us in these cases, as it makes it easier for me to explain and share our experiences. The phase explore is when you have taken a decision to explore possibilities and you're ready to reach out to our partners and suppliers. Start with finding a partner with prior experience and work together. Someone can help fine-tune the scope and looking at the technical needs to plan for the most suitable solution within the time scope that you have set. A partner can share knowledge and expertise while your own organization is learning. At Inmotion, we have presentations, documentation, manuals, and data sheets that can help increase knowledge. Make sure to allocate and take time to read the literature. Many times, time to market is important, and working together with someone helps to make the choices to select a solution that will work after the introduction, when it's more difficult to change conceptual strategies. Share objectives and needs early. Avoid locked-in solutions. For example, share and explain overall objectives on product and system level. Together when you share technical specification or your own developed functionality. If a supplier knows what is important, it is easier to suggest alternatives and better solutions. If done early, it is a lot easier to change the scope and possibly without changing time to market. Setting up an NDA is a simple way to get started with the supplier. Illustration and videos of present product can help a lot with understanding your functional needs. Whenever possible, try to think electric from start. Avoid small adaptations in incremental steps. Many of our customers are replacing internal combustion engine products, ICs, with a long history. Consider a shift rather than small steps that can be more successful. Identify rules and regulations such as EC machine directives, UNEC type approvals, CE, UL, and so on. Make sure to identify rules and regulations early. Looking at fundamentals, start looking at basic installation early as well. For example, coolant hose layout, we have seen difficulties in the installation. Something that can be difficult and both expensive and time-consuming to change later. When fitting the product, make sure you have room for hoses and harnesses. Another advice, avoid long AC power cables between the inverter and motor. If needed, it is better with more length of the DC cables between the inverter and the batteries. Share your harness layout for CAN communication, the topology. This is where many of our customers have had trouble. Not related to the inverter necessarily, but we are many times involved in the fault searching, especially termination and cable length is something to look at. Share what temperature and speed sensors is going to be used. Make sure temperature sensor is compatible with the inverter, especially the supply voltages. Consider using standard I/O functionality and inputs and outputs. Make sure to follow guidelines of grounding and shielding, that type of information that can be found in the manual. If you can share wire diagram and harness layout, we can also give feedback to that. Third phase is to define, including a pre-study, defining the scope, and start prototyping. When considering system architecture, include motor and inverter and sensors, such as speed and temperature, all together as one package or a system. Avoid selecting motor first and later inverter, because that maybe you're doing that because you're optimizing the motor itself. But doing that way, you may risk to end up with more expensive inverter. For example, due to that the motor requiring high currents. They should all be designed as a package. Define what functionality should be in the inverter and what should be implemented in a master controller. We can do both, but define it early to avoid long discussions later with possible need for redesign. Describe interfaces and system layout, include and share data sheets with temperature and speed sensors. Share CAN topology. What are the other nodes that will share the same CAN bus? Inverters can also have digital inputs used for other type of functionality that might save other type of hardware, additional hardware. Try to make use of what is available. Share what functionality is requested, and many times it is available as a standard functional or solution. For example, torque control, standard interfaces with built-in functionality, and so on, parking brake. Agree on a clear plan for functional growth, what is needed early and what can wait to be released later. Avoid a big bang delivery just before product launch. Share requirements for functional safety and possibly cybersecurity. Select the framework, including regulations and standards. Will the application be controlled by a machine directive or automotive type approval, for example? Functional safety relies a lot on the hardware that you will be using, but it is also important to consider the software functionality and the way that you're developing your solution. Many customers are now asking for functional safety according to ISO 13849 with certain performance level required. It is then important to share your safety functions in order to propose standard sub-safety functions from us. Best is, of course, if there is a harmonized Type C standard, such as 1175 for industrial trucks, for example. Make sure to allocate sufficient time for working with prototypes to test during functional growth. We would propose to create a test environment that can test without too much limitation and low effort. Somewhere you can play around and explore performance and behavior. Best would be to include whole package with motor and external load that can be controlled, some kind of test bench or even a test vehicle as early as possible. It is sometimes possible to do motor tuning in the vehicle with the help from our auto tuning tools. But in that case, it is preferred if the motor rotates freely with only a type of flywheel, adding inertia. For example, tuning a traction motor with vehicle lifted so that the wheels can spin freely could work better than auto-tuning a pump motor. If pump motor, it needs to be disconnected from the hydraulic system, pump system. Make sure to include us and ask for advice rather than inventing new unproven solutions that can be very time consuming. It is important to have a good requirement specification that is clear with just enough information. It's important to have the requirements easy, so they are easily understood and not too detailed. Don't try to overcomplicate requirements. Fourth phase is development. When this far, it becomes very important with collaboration. It is good to include many parts of your organization, such as operation and after sales. Maybe you have many production sites around the world. Check if there's any region-specific requirements, including software download and part numbers, as it can affect safety and need to be tested all over again. Ask after sales how to manage the product in the workshop. For example, include instructions what to report if there's any worthy case to avoid additional costs. To make collaboration and communication easier, agree what tools to use. Microsoft Teams and Google Meets offer fantastic solutions that are easy to use. Make sure your IT organization will not limit you when you're working remotely together with us. Can be meetings, sharing specifications, and supporting remotely using a remote desktop. Meeting in person, of course, between technical staff helps build trust and would make collaboration work faster and easier. When asking for support, make sure to include as much information as possible. That will save a lot of time. We have tools to make it easier to tune motors and fault search functionality and communication, setting up parameters and downloading software. Use what is already available. Make sure to have tools to log and analyze data and when building debugging. Iterate your product development. Try to enable your organization to receive continuous software updates during the development phase. This will help avoid critical bugs later and functional growth will become faster. Make use of priority, where must-have functionality is developed first and later followed by nice-to-have features. Many times, new must-to-have requirements come up while testing, and it is better they get done early to avoid delaying time to market. Avoid late hardware changes, for example, interface, sensors, and motors. For testing, make sure to add sufficient time for verification and validation. And my last advice during development, automate as much of the testing as possible. That will save time when working iteratively and avoid making mistakes. Continuation, last but maybe the longest phase, when you have launched and put your first product into production. Many times, this is when you want to reuse design concept that you already shared in your design phase. If we have thought about the next step earlier, it could be as easy as using same concept with different performance, meaning sizing of equipment and products. Maybe only do a tuning for new configuration. Many times, system architecture and functionality can support the same type of operation, but with different performance criteria. Once you have put your product in production, you may want to improve while volumes increase. It is important to have an agreement what happens when problems are reported from your customer. If returning units to us, for example, it will help a lot if as much information as possible are included. That could help to avoid no fault found and give you answers faster, especially if the root cause is something else not related to us as a supplier. For service and after sales, decide if you would develop your own tools for service and repair or use tools that are already available. We have tools for fault searching and updating software. During the design phase, it is good to consider how to use part numbers. It is possible to use hardware IDs to have a single software and hardware with multiple application purposes. For example, different tuning for different product models or different purposes on the same machine. Could save a lot of effort and less space needed in your warehouse and logistics later if you are reusing the same hardware and product. That was the last page of this presentation. Thank you very much for listening. I hope that you have more questions. Can we see any questions? Or we get the questions.
Yes, we have just switching on my screen here. I hope that you hear me. There's a question here, Anders. What do you find the most difficult part, or where it gets the most tricky in the process of that you just described, going to the market? So, what is the most tricky part?
Finding out late that other type of functionality is needed.
Okay, so late delays is really something that is
late changes.
Late changes. Okay. So the ideal part is that the customer, the project, you have well-defined requirements from start. And from that, you basically know what to implement. Is that what to interpret?
And also give time to iterate together. So as clear as possible from the beginning and as wide description as possible so that we get a deeper understanding of the whole product, not only our part or the inverter responsibility.
So the good understanding of the board system, the purpose of what you are to develop and deploy, and also you mentioned about the functionality or the safety parts. How can you support with the safety parts during this process?
So many times, if you have done a safety concept or safety functionality yourself, it is good to describe the whole safety function and not only the sub-safety functions. That is the requirement to us. Because then we can propose standard sub-safety functions and maybe with little change on your side, it will speed up the total development.
Okay, so necessarily it's not the assumption that you made from start that it's the correct one. So in the discussions that you have with Inmotion and the application team, you might find faster ways to electrify the vehicles. Is that
using tools that are already available functional?
Can you describe that? Is that having it instead of having one sensor, it might be multiple sensors, or to get better coverage from start? Is that the way to go about it, or?
So if we take the example of the safety functions, if we have standard safety functions that you could use out of the box, there will be needing less development and less testing, and information and material is already available.
Okay. So then it's speeds up the process really from development and hitting the market faster. Correct. Very good. So another question here is, do we need to decide initially what kind of hardware we are to use, or is that something that we can decide on together in the project?
So if we are part of selecting the whole system, including the motor and sensors and inverters, we can probably suggest a more optimized total solution.
Okay. And another part is, another question that came here was, do we support all kind of motors or electrical machines? Or are there any limitations there?
Oh, that's a question I need to pass forward, I think.
Okay.
But we have PM and induction motors.
But
If there's any, what we can support or not, I think.
But PM and induction is kind of the standard ones that you use most of the time. But there are other motors as well. And one other question is, does this apply to low voltage only, or is it both high and low voltage solutions?
So the presentation that I have referred to includes both low voltage. For us, that means below 96 voltage, high voltage, which is up 96 for us. So there is no difference. The difference is between if it's more towards automotive or it's more machine-directed machines.
Very good. And the last question, you mentioned that you have application engineers in Stockholm, but the projects that you run is not only in Stockholm, they are across Europe and Asia, around the world, I guess.
Yes, so there is Inmotion application engineers in the US, Asia, Japan, Korea, and we have,
so across the world, basically. So you and your team will be able to support wherever the customer maybe is situated.
Yes, we're used to working with remote customers.
Excellent.
But I should say it's always good to meet in person at least once.
Absolutely. Absolutely. That's good. Okay. Thank you very much, Anders, for
Thank you, everyone, for listening.